All right. So for the next two problems that we're going to be dealing with, we're actually going to be dealing with history, which is actually pretty cool because you guys have actually been talking about the amendments and the Constitution in some of your guys' classes in history class, and which I think is very cool because it actually does tie in math. You guys look at charts and stuff like that. Well, we do as well in math class. So in this problem, we're talking about the 1920, the ratification of the 19th Amendment to the United States Constitution, which gave women the right to vote, which I personally think is pretty cool. I can't imagine what the world would be like if women didn't have equal rights. And getting the right to vote is actually pretty awesome and was one step closer for us women to have equal rights. But that's just an opinion. So the table below shows the number to the nearest million of votes cast in the presidential elections, both before and since women were able to vote. Explain how you know that the table represents a function. Graph the function represented by the table and describe any trend in the number of votes cast. All right. So how do you know that the table represents a function? Look at our x values. Remember, x is the input. Y is the output. So this is the x, this is the y. X is also, what word do we use for x? Is it domain or is it range? It's domain. This is the range. Okay. In order to be a function, every input has to have exactly one output. And if I'm looking at my inputs, every single input has exactly one output. Okay? There's no x values that are repeated. Right? So in order to be a function, every input has to have exactly one output. There's no x values that is repeated. Okay? So, every input has exactly one output, which means no x values are repeated. Okay? That's how I know that is a function. All right, so let's graph this. The graph paper is on the next slide. So I'm going to be going back and forth to this. Looking at the table, what is year 1920? And how do I know that? What is year 1920? And how do I know that? It kind of gives you guys a little bit a hint when it says years before and since women were able to vote. So think about that. When would it be 1920? Would it be negative 10, negative 12, negative 8, negative 4, 0, 4, 8, or negative 12? Good. It's going to be the 0. It's going to be my starting point. So this is actually, this order pair right here is 1920. So after the amendment passed in 1920, only 27 million women voted. In the presidential election afterwards, so this was actually 19 what? Good. 1924. This would be 1928. And good. 1932. And you can see it goes up, doesn't it? Okay, going backwards. This would be 1916. 16 minus 4 is 12. 12 minus 4 is 8, so 1908. Okay? So even in 1908, there were women that were voting. They were getting around the laws somehow. Okay? But it really didn't take off until after the ratification of the 19th Amendment. Right? So let's do what it says and B and graph it. So again, since my x-axis is only from 0 and it goes by 4s, can't I go by 4s on the x-axis? Yeah. So I can go by 4s on the x-axis. I can go by 4s on the x-axis. So let's label our x and y axis. And on the x-axis, we need to label it what? Good. Years before or since 1920. That way we realize that this 0 is 1920. Okay? And we can say this is 4. This is 8. This is 12. And do the exact same thing going backwards. So every other 2. So this is -4, -8, -12. Take a look at our y. Our y says votes per million. Okay, so we needed to label our y-axis. Our y-axis is going to be votes in millions. And it's important to realize that that is votes in millions. Because we're actually going to be plotting small numbers, but millions is actually a big number, isn't it? So we are plotting small numbers, but these are actually big numbers because it's actually in millions. And it's important to realize that. That's why your labels is so important to have. All right, what is our smallest number? Our smallest number is 15. And our largest number is 40. Okay, well, obviously, I'm not going to be able to get 40 up in here. Okay? But what can I go by up here that could help me get to 40? I could go by 5s. 5s would be realistic. 5, 10, 15, 20, 25, 30, 35. Nope. Can't do it. We could try it out. Not going to work because I need to go to 40. So what do you think will be my next best if I can't go by 5s? I could probably go by 10s. I can say 10, 20. I can say 10, 20, 30, 40. Okay? And again, we did not go the same amount as we did on the x-axis, but we were consistent on the y-axis. All right, that's what matters. Okay? So let's take a look. Our first order pair, -12, 15. So what do? -12. 15 is where on the graph? Halfway between 10 and 20. So here's that. Go back to our graph, our box. Look at our next point, -8, 15. Okay, well that's easy. We know where 15's at. So here's -8, 15. Okay, 4 is -4, what? 19. Okay, well -4 is here. 19 is getting closer to what? Good, 20. So it's not right on the line, but it's close to it. Okay. 0, 27 is our next one. So here's 0, 27's closer to 30. Okay. Our next point is 4, 29.